Hello everyone, this is Ivan Nos, your tutor for today's topic, the Bairstow's Method. The Bairstow's Method. It is a method that can be used in finding the value of the real roots in a equation. In some reason, it is similar barely to both Muller's and the Newton-Raphson method in terms of its procedure. In order to get the roots in the equation, we must make the following steps. First, guess the value for the root x sub I. We must assume first an equation in order to find a way to guess the real root. Next, divide the polynomial by the factor of the initial guess. And the third step is determine if there is a remainder. This remainder is crucial in this method because as long as we get a remainder at the final answer, our answer is still far from the true value. So, we must iterate for more until the remainder becomes 0. The formulas in this method are the following. B sub n equals to A sub n. Bn sub negative 1 equals to an sub n minus 1 plus r times b sub n. Bi equals to a sub I plus bi sub I plus 1 plus s times b sub I plus 2. And for the c sub n equals to b sub n, c sub n minus 1 equals to a sub n negative minus 1 plus r sub n. C sub I equals to b sub I plus r c sub 2 plus 1 plus s c sub I plus 2. C sub 2 delta r plus c sub 2 delta s will be negative b sub I. C sub I times delta r plus c sub 2 delta s will be the negative b sub o. The value of the root can be determined at the final answer depending on the form of the final answer. If the final answer is a third order polynomial, or greater, we must repeat the procedure and iterate more by doing the Bairstow's method again until the answer becomes a single polynomial. If the final answer is a second order polynomial or quadratic equation, the first root is already given. So the remaining two roots must be solved using this formula. X equals to r plus minus r sub 2 r squared plus 4s over 2. With this we can get the remaining two roots in order to complete the answer. If the answer is a first order polynomial, the answer will be just substituted in this formula. X equals to negative s over r. To elaborate further, we get an example. The R and S will be negative 1 and the E sub S or the error will be 1%. First, we must get the B and B, these variables. The variables for this equation will be b sub o equals negative equals 1, b sub 5 sub I, b sub 4 equals to negative 4.5 as stated in the formula, b sub 3 equals to 6.25, b sub 2 equals to 3.375, b sub I equals to negative 10.5, and b sub o equals to 11.375. Next, as we get this answer, let's get the C. C sub 5 equals to 1. C sub 4 equals to negative 5.5. C sub 3 equals to 10.75. C sub 2 equals to 4.875. And C sub 1 equals to negative 16.375. We get these answers based on the formulas that given at the equation. We just substitute the suitable values in these equations. Next, we get this. You must perform this formula. C sub 2 delta r. C sub 2 delta r equals to negative 4.875 delta r plus 10.75 as the C sub 1. The answer will be delta S equals to 10.5 negative 16.375 delta R plus minus 4.875 A sub S delta S equals to negative 11.375. With the process of elimination or substitution, the delta R will be 0.3558 and the delta S will be 1.1381. Then we substitute it to the formula. Negative 1 plus 0.3558 equals to negative 0.6442. S equals to negative 1 plus 1.1381. The answer will be 0.1381. Then we perform this formula for getting the approximate relative error for the R and S. Delta R over R times 100 equals to 3.558 over negative 0.6442 times 100. The answer will be 55.23. The next the absolute relative error for the S will be delta S over S plus times 100, what equals 1.1381 over 0.1381 times 100. The answer will be 824.1%. As we see this, the error is so high, so we must iterate in order to reduce the error at the remainder at the R and S. After the second iteration, we get the EAR will be 26% and EA sub S will be 17.6%. But still, the error is still big, so we iterate more. After 4 iterations, we get this answer. Equals to 0.04%, which means that we get nearer to the true value. Then we must substitute it to the formula that are given, which is x equals to r plus minus r squared plus 4s over 2. Negative 0.5 plus minus negative 0.5 squared plus 4 times 0.5 over 2. The remaining two roots will be 0.5 and 1. Then we substitute it to the equation f of x equals to x cubed minus 4x sub 2 5.25x minus 0.10. As we see this, it is a third order polynomial, so we must perform another Bairstow's error. Bairstow's method. After 5 iterations, and the R in this and R and S in this equation will be 0.5. Negative 0.5 is the R and 0.5 is the S as the initial guess. After 5 iterations, the R will be 2 and S will be negative 1.249. Then we perform again the formula, this formula equals to 2 plus minus 2 squared plus 4 times negative 1.249 over 2. The answer will be 1 plus minus 0.499 I. Which means that the remainder in this formula will be R equals to 2.